Okay, hi, good evening, everyone. I hope my voice is audible and you're able to see the screen. Can you give a heads up in chat box? Good evening. Yes. Okay. Right. So, start panlama. So now we are here in the last day of your data science internship. Yes. So far in the 4 days, what we have seen is we've seen about what data is. Yes. What data is, how it gets, what is the role of this particular data in data science, and from where you collect data, and then how you write code, Python code, to extract data and clean the data, and then how you visualize the data. Yes, we also saw about database concepts, we saw packages, um, packages and all this. Yes. So today, what we will see, first day, I told you there is a process in data science, right? Initial process is data collection, and then data cleaning, and then data analysis, and then the fourth stage is data modeling, and then visualization. In this, we have seen about data collection, we've seen about what is the data cleaning, we've seen about data analysis and visualization. So one thing which we didn't see is the data modeling. Yes. So we'll discuss about data modeling today. Now, what is data modeling? For data modeling in data science, we have many algorithms which are predefined. We have many algorithms which are predefined. Okay, you call them as machine learning algorithms. So what we are going to do is, with the data what we have collected so far, we are going to apply algorithms to those data. Okay, we'll apply algorithm to that data, and we'll see how we can train that particular model. Okay, we'll see how we can train that particular model, and we'll see whether it is giving the right output or not. In general, what is an algorithm? It's just a step-by-step process of how something should happen, right? When it comes to program or code, there is like steps which it should follow so that you get the required output. Yes, that is an algorithm. Now, here in machine learning or here in data science, when talking about algorithms, you have different types of algorithms. Say, for example, you have one type called supervised algorithms, and then another is called unsupervised algorithm. Supervised and unsupervised. Now, what are supervised and unsupervised algorithm? Just as the name implies, if you have to tell something what you have to do in step by step, then that is supervised. Now, say for example, you were coming to me with a problem. Okay, you have a problem with you and you're coming to me and I'm giving you a solution to how you should tackle that problem. That is called supervised. Unsupervised is you're coming to me as with a problem, but I'm not giving you the solution. I'm asking you to get a solution by yourself. I'm asking you to find solution for your own problem. That is unsupervised learning. So one is supervised and another one is unsupervised. So in algorithms, you have different types. So we have algorithms like linear regression, logistic regression, decision tree, random forest, k-means, and all these algorithms. Okay, this linear regression, logistic, decision tree, random forest, all this comes under supervised, and classification algorithm comes under unsupervised algorithm. Okay, so we'll discuss about these. I'll try to explain how each algorithm works along with one example so that you'll understand. Okay, so in that, the first one is the linear regression model. Okay? Linear regression model. Now, what is linear regression model? The example which I've given here is, now imagine you are going to play any sport. Okay, you're going to play any sport, and you're going to calculate based on the number of hours you practice what is the score you might get. Okay, so if you practice for more number of scores, more number of hours, obviously your score is also going to be high. Yes, so let's say You're practicing for 4 hours. If you practice for 4 hours, let's say assume your score will be 10 when you practice for 4 hours. When you practice for 8 hours, your score is going to be 15. When you practice for 10 hours, your score is going to be 18. So when the number of hours increase, your score also increases. Yes. So to find out the progress, we'll use linear regression. So in these cases, you're going to use linear regression model. Okay. So first example, what we will see for linear regression will be ice cream sales. So based on the temperature, we are going to find the ice cream sales. So this, now let's say you have a data with you. You have 4 days data with you. Okay. Day 1, we have temperature 30 degrees Celsius. And on that day, we've sold 40 ice creams. Day 2, we have 35 degrees Celsius and we've sold 50 ice creams. Day 3, it is 40 degree and you've sold 60 ice creams. And day 4, it's 45 degree and you've sold 70 ice creams. This is the data which you have. Now with this data, you're going to prepare a model. Okay, you're going to prepare and train that model. And after you train that model, you're going to give a temperature. Let's say if the temperature for today is 50 degrees. How much ice cream will I sell for today? So you're going to ask question to that model. And based on this data, that model is going to give you the answer. All right. So step by step, let's see how it is done. Now, the first option, this first program, I've just elaborated a little bit bigger. And there is another program, second one, which is again a shorter version. Okay, I'll show you both the options, right? So first option, first what we will do is we will plot the data. Now, whatever data we have, we'll plot and we'll see. So for plotting the data, I have taken the data into lists. So the temperature value and the ice cream sales value, I've created list and I've used a scatter plot to plot the data. Now, when I plot this data, let's see how it looks like. I'll just copy this. I'll go to PyCharm. I'll paste it here. So we have the sample data, which is plotted in a scatter plot, and we'll see how this scatter plot looks like. See, this is a scatter plot, and for the x-axis has the temperature and y-axis has the ice cream sales. So for 30 degree, we have sold 40 ice creams. For 35 degree, we've sold 50 ice creams and so on. Okay. So it's a graphical representation of the data which we have by default. All right. Now, in linear regression, what you need to find is the line. You need to find a straight line. It looks something like this. See, this red line in linear regression. This line will help you identify based on your x-axis and y-axis how much the ice cream is going to get, sold out, right? So first you need to find that line. To find that line, you have a formula that you have to calculate. Hopefully, I think you should have learned about this linear regression somewhere in physics in school. Yes, the formula to find, so that you can get the line is sales equal to intercept plus slope into temperature. This is the formula. Don't worry about the formula. Here in this formula, we know two details. One is the sales detail, another one is the temperature detail. Yes. Now our work is to find the intercept and the slope. You need to find the intercept and slope. For this, you have default formulas. To find intercept, you have one formula, and to find slope, you have one formula. That is the code which I have written here. So to calculate slope and the intercept, you have to use a formula. You have to find numerator, denominator, and using that numerator and denominator, you will find slope value and intercept value. Okay. So this is again one formula which I have applied to find out the intercept and slope value. Now let's calculate this intercept and the slope value. So I'll just copy this code. I'll go to PyCharm. I'll remove this. I'll take the import statement, put it at the top. Yes. So now what we have done here is we have the sample data which we have converted it into NumPy arrays. And then we have used those NumPy arrays to calculate the mean value, and we have passed those values to find the slope and the intercept. So now when I run this program, we're going to get Okay, I think I should close it. We have the intercept value and we have the slope value here. Now the formula is complete. Okay. So once the formula is complete, what we are going to do is we are going to make predictions. Now we are going to check if the temperature is 37 degrees, how much ice cream will be sold. We are going to check that. Okay. So for that, I am giving a value new temperature is equal to 37. And then we are going to write that formula. Predicted sales equal to intercept value we have, slope value we have, and the new temperature we have. So I'll just copy these three lines and I'll put it here. So now, if the temperature is 37 degree, the amount of ice cream that will get sold will be 54. This is the answer. Now, let's plot this so that we'll find the line. Now, we are going to create the regression line. So, with the formula which we have, we'll create the regression line and we'll plot it. So, when I plot it, first we'll use the scatter plot to display the temperature and the ice cream sales. All right. And then we'll create the regression line and we'll pass it to the plot. So, regression line I've created with the help of our formula and I'm passing it to the plot function. And then I'm trying to run this. So when I run this, you will get the plot here with the red line. For 37 degrees, the amount of ice cream which will get sold is 54, right? And see here, where is 37 degree? 37 degree comes somewhere here. And for 37 degrees, the red line crosses 54. Okay, so this line will denote like as per the temperature how much ice cream will get, it is going to get sold. Now based on this image, you can change the temperature value here. Instead of 37, try giving 44, and if you give 44, it should give you answer somewhere around 65 or 66 ice creams which is sold. So based on this, you'll be able to find out how many ice creams are sold. So this red line will indicate the progress. Okay, so how did we train this model? We gave default data. Yes, we've given the data set, and based on this data set, this model is able to, predict the value. Right? This is logistic regression. Now, this I showed you as three parts: giving a data set, and then calculating intercept slope value, and then predicting value and visualizing. Now, I'll show you another program which will do all this in a shorter version. Right? Next program is let's assume you have a lemonade stand and you're going to calculate how many cups of lemonade you will sell and how much money you will make. Okay, so we have the data here. If you sell 1 cup of lemonade, you're going to earn $2. If you sell 2 cup of lemonade, you're going to earn $4. If it's going to be 6 cup of lemonade, you're going to earn $12. This is the data which we have. Okay, so what we'll do is in Python, you have this sklearn package. Okay, skykit learn package. That package has all these algorithms predefined, all the functions, calculating intercept, slope, everything is predefined there. So you don't have to go sit and write all the formulas and all. So all that you have to do is we'll pass the data first. Okay, and then we'll create the linear regression model, and using the fit function, we are just going to give the data which we have. That's it. With these 2 lines, the model will get ready. You don't have to go calculate intercept value, slope value, all that separately. No, it is going to do all the process on its own. So you will just create the linear model, and then you're going to train the model by passing the data which you have, the number of cups sold and the money made. All right, and after that you're going to predict. So you're going to predict if you're going to sell 11 cups of lemonade, what will be the amount that you will make, how much dollars will you make. So you're asking if my value is 11, if the number of cups sold is 11, what would be the answer? That's it. And then you will print the result, and then we have a plot as well. Now I'll copy this and I'll paste it here. So look at the order we have imported. Okay, and then we have the data. Yes, the cups sold and the money made, and then we are creating the model and we are passing the data to that model. So now here the model gets trained with the existing data set. Okay, And then you're asking if I'm going to sell 11 cups, how much amount will I make? And it will calculate and give you the answer. And then it will also give you the plot. Now, when I run this, okay, see here, the predicted money made if 11 cups are sold is $21. So if you sell 11 cups, 11 comes somewhere here, right? So when you sell 11 cups, you're going to earn at least $21. If you expand this image, I think you can get a few more data. All right. This is with linear regression. Yes, you understood. So training a model is something like this. You have to give the data set, and then you have to use the default functions, and then ask for, give a value and ask it to predict. It is going to predict and give you the answer. Linear regression is as simple as that. Next comes logistic regression. Now, logistic regression is where it is going to just give you answers like true or false. Okay, so it is like probability of whether an event will happen or not. That is logistic regression. Now, say for example, we have a group of students, and based on the number of hours the students study, we are going to find whether they will pass or fail. Okay, so if a student studies for like 3 hours, he'll fail. He studies for 4 hours, he'll fail. He studies for 6 hours, he'll pass. So based on the number of hours a student studies, we are going to find out whether he'll pass or fail. So it is going to give you a probability value, not the accurate value. It is not going to tell you exactly whether he'll pass or fail, but it is just going to say the probability. How it is finding the probability? Based on the data which you give to that particular model. So here we have a data. We have a sample data. See here, we have study hours. So if the here 0 means fail and 1 means pass. Okay. So if a student studies for 2 hours, he is obviously going to fail. 3, 4, 5, 6, he is obviously going to fail. 7, 8, 9, he'll pass. 9 and 10, again, he is going to pass. Okay. This is the model data set which we have. Model data set which we have. So first you have to input the data. Whatever data you have to input that. And then here in this linear regression, you don't have to draw a straight line and all, because you are going to find the probability only. So it will not give you straight line. Straight line is only with logistic regression, not with linear regression. So here this model is going to give you a probability between 0 and 1. So the value which you will get will be between 0 and 1 only. All right. So what we'll do is, okay, we'll see the code. So here we'll import, and then we'll give the sample data, study hours, and the exam outcomes. And then we are going to reshape this data. Why we are reshaping this data? We have 2 arrays, right? So we are just reshaping it into something like, one column, and it can have as many rows. We're just reshaping this only because only then this logistic regression model will accept. By default, it will accept only this type of data. So you're just reshaping whatever data you have, and then you're passing it to the model. So you're creating logistic regression model, and you're passing the X and Y values to it. All right. Now, after you pass, we are asking that model. See, if a student studies for 5 hours or 7 hours or 9 hours, what would be the probability? Will he pass or will he fail? Is it 0 or 1? We are asking it to find it. And since we are giving 3 values, I have written a for loop here. If it is just one value, you can directly write the print statement, but you want the output for all the 3 values. So I have written a for loop here to print all the 3 values. Let's copy this. And I'll paste it here. Okay. And let me run, stop and rerun. Yes. So if a student is studying for 5 hours, see here the output 5 hours. The probability is you will either get 0 or 1. As I said, you will not get the accurate value. So the probability is 0.3. That is almost it's like failing in an exam, right? So if he studies for 7 hours, the probability is 0.8. 0.8 is somewhere near 1. So he's obviously going to pass. Probability of him passing is 0.8. And if he studies for 9 hours, the probability of passing is 0.9. Because here in this data set, see, for 7, 8, 9, we've given pass values. That's why the value here is somewhere around 0.98. And for 5 hours, we've given it as fail, 0 option, and that is why it is very low, 0.3. Okay, so based on the data, it is going to just give you the probability value, not the accurate value. Now, if you ask me whether this is how it is going to happen, no, you can't justify this, right? You can't be very sure of this. Sometimes a student might study for 2 hours and he can still pass. Yes, so that is why they call this probability, finding probability. And one another example is this again. Okay, this example I leave it to you because I have one such for your assignment. Let me check what assignment I've taken for you first today. Your assignment for day 5, logistic regression to predict whether customer will subscribe to a service based on their monthly income. Okay. Okay, so this is with monthly income. Here I have age. So I'll show you this program. Now, this program for logistic regression will predict whether a person will buy a product or not based on their age. Okay, so this is the person's age, and based on their age, we are predicting whether he's going to buy the product or not. Again, we are reshaping the data and you're passing it to the logistic regression model, and then you're passing some age. What if the age is 20, whether he'll buy or not? What if his age is 33, whether he'll buy or not? And what if his age is 50, whether he's going to buy or not? Right? Again, you're going to get the probability value. Let me run. Okay, so if his age is 20, the probability of him purchasing that product is 0.4. Okay, and 33, 0.5, and 50, 0.58. Again, it is a probability value. Now, based on the same example, you have an assignment program as well, but not with age, but with the income. All right. You can use this program and try that. Right. Next is the decision tree. Decision tree algorithm. Okay. Now, decision tree algorithm is going to ask many questions. It is going to ask many questions and only then it is going to derive an output. Okay. Now, see here. See this particular template. Now, here Outlook defines the weather, whether it is sunny or overcast or rainy. Okay. Right. Now, if the weather is sunny, next it is going to ask how is the humidity. If the humidity is high, now this example is based on the temperature, based on the climate, we are going to determine whether a player can play or not, play for today or not, whether he can play tennis or not. So if the weather is sunny, next question it will ask is how is the humidity. If the humidity is high, it means the player can't play. If the humidity is normal, the player can play. If the weather is overcast, yes, he can play. And if it is rainy, it is a direct no, he can't play on that day. So it is going to ask multiple questions, and based on those multiple questions, it is going to predict values. It is going to say whether a person can play that day or not. All right. So for this, we'll take the same example. We'll take the same example, and here what we have is we have a data of the possibilities. Okay, this data which we have here is the outlook, temperature, humidity, and the windy. So if the outlook is sunny, if the temperature is hot, if the humidity is high, and if it is windy, if all this is on that particular day, it has to give us whether answer is yes or no. Here I've given answers at the bottom. Now the X value will denote the climate change and the Y value is going to denote whether you can play or not. So if it is sunny, if it is hot, if the humidity is high, and if it is not windy, you can still not play. Why? Because the humidity is high, so you can't play. If it is sunny, if it is hot, if the humidity is high, and if it is windy, again you can still not play. So the second answer is also no. If it is overcast, again if it is hot, if it is high and there is no wind, yes, you can play because it is not sunny. Overcast is okay for playing. Overcast is somewhere like not very sunny, not very cold kind of climate. And if it is rainy and if it is mild and if the humidity is high and if it is not windy, yes, you can still play. So based on what we have written here, the probabilities, I've given yes or no values here. Okay, so now we have the data set ready. Okay, we have the data set ready. Now, what this data set will do, this data set is all about characters and alphabets, right? But models understand only numbers. When you pass values to models, data to models, it is going to understand only numbers. So we use something called label encoder, which is going to convert this entire data set into numbers. Okay, after it converts it into numbers, we are going to create the decision tree classifier and we are going to pass the dataset value. Okay, we'll pass the value. After the classifier is ready, now the model is ready. Now once it is ready, we are going to give test data. So in my test data, I'm going to ask, the climate is going to be sunny and it is going to be hot. The humidity is going to be high, but it is not going to be windy. Windy is false. So which means based on this, you tell me whether a player can play or not. And another training set is the climate is going to be rainy, but it's going to be mild, and humidity is going to be normal, but there is going to be, it is going to be windy. In this case, whether the player can play or not. So it is going to give me yes or no answers. All right. And then you're going to print the answer. Copy this and paste it here. Yes. So you're preparing the data set and then you're converting the data set into numerical values and then you're creating the classifier and you're passing the data set value and then you're testing the data set and then you're printing the output. This is the order of this model, right? Now when I run this program, okay, so it's sunny, it's hot, and the humidity is high. Yes, even though it is not windy, the humidity is high. So the answer is no. It's rainy, it's mild, the humidity is normal, but again it is windy, which means again a player can't play tennis. So again the answer is no. You can change these values. You try changing these values and see whether you're getting yes or no answers. Okay, so it is asking as many questions it can and then it is coming to a conclusion. That is decision tree. Before coming to conclusion, it is going to ask lot many questions. All right. Now in decision tree, we have another one called random forest. Okay, random forest is another type of algorithm. But before that, let me share the attendance sheet for online participants. Fill in your attendance sheet and continue with the class. Okay, now this random forest algorithm, it is used for both classification and regression tasks. You can use it for both. You can classify and you can take it for regression as well. Now here, we'll consider one example. We'll see, you all know this Gmail feature, right? So normally when you receive an email, if it is a kind of spam email, it directly goes to spam. And if it is a normal email, it arrives in your primary box. Yes. So we'll take the same example. So we are going to give a few data set to our model and then we are going to train that model and then we'll give a sample email and we'll ask whether it is a spam or it is not spam. So we'll ask the algorithm to find out whether the email is spam or not spam. All right. So for this, what you should do first is you have to prepare the data. So you have to have the data set with you, like the email content, whatever you want. If you have to prepare it well, no? So you have to give all the types of emails both spam email and not spam email. And then you have to train your algorithm, and then you will vote for your algorithms. Like, whichever email is spam, you will vote as 1, and whichever email is not spam, you will vote as 0. With this way, it is going to get trained, and after it gets trained, it will start predicting. Okay, so here, look at this example. Now, in this example, we have some email contents here. Now, the email content here, the first email: congratulations, you won a free vacation. Click here to claim your prize. Is this a spam email or a normal email? Spam or normal? Spam. Looks like spam, right? Okay, so this is spam. Meeting tomorrow at 10 a.m. in conference room A. This looks like a normal email. Get cheap medical pills, no prescription needed. Spam. Reminder, your appointment with Dr. Smith is scheduled for Friday. Not a spam. Yes. So we have 4 data sets, 4 sets of emails. And for these 4 sets of emails, we are also creating another label which shows whether it is spam or not spam. So the first email content is a spam. So I've given value 1. The second one is not a spam. So I've given value 0. Ham is nothing but not a spam. All right. Get cheap medical pills. Again, it is a spam. So I've given 1. And reminder, your appointment. Again, it is not a spam. So I've given 0. Now we have 2 data sets here. Okay. Now what we'll do, after you give this data set, initially you should actually, when you give any data to a model, you should first clean that particular data. Like here, what we are doing is we are removing all the non-alphanumeric characters like spaces, empty spaces, numbers and all that, and we are converting all the letters into lower cases so that the model will feel free to get trained. All right. After that is done, after everything is done, what you have to do is you have to pre-process all your emails. Why are we pre-processing our emails? Because now the model is actually going to count the words which are repeating. It is going to go through each and every word in your email, and it is going to see which word is repeating. So it is going to count. It is going to use the vectorize function, and it is going to count words which are repeating, and it is going to take it one time. All right. So after you do these 2, you're going to create your random forest classifier, and you're going to pass your trained data. Okay, so once you pass your trained data, the data is ready now. So the data is actually ready with classifying whether it is spam or not spam. And then what we are doing is we are going to give a sample email. This is our sample email. So our sample email is, hey there, I hope you're doing well. Let's catch up. And we'll ask whether this particular email is spam or not spam. We'll pass it to the classifier and we'll ask whether it is spam or not spam. So then we are using an if condition here. So if the prediction 0 is equal to, prediction is equal to 1, then it means it is spam. If not, it is not a spam. Okay, so now, hey there, I hope you're doing well. Let's catch up soon. Is this a spam email or not a spam email? So what output should you get? 0? Yes. So when I run this, the email is classified as ham, which means not a spam. Now let's change this. I'll change the content here. Hi, let's go to a free vacation based on the training data set. So I have a free vacation set here. Okay. Let's go to a free vacation. Now this is one data set. Okay. So here, free vacation, the data set which we gave here at the top, we've classified that as spam. So now when it sees this content, free vacation, it automatically it comes to a conclusion that this particular mail is a spam. Even though if this is a valid email, we'll still consider it as a spam email only. So I'll save and I'll run. It should show the email is classified as spam. Okay, so it is based on what data set you give and what labels you apply to that data set. Based on that, it is going to classify. This is random forest. Okay. Next comes the clustering part. In general, what is a cluster? What is clustering? Grouping. Yes. In general, clustering is nothing but grouping. Now, here we have 30 students who are sitting here. Now, if I wanted to group you people based on what color dress you are wearing, yes, all black color dress into one group, all green color dress into one group, yellow color dress into one group. Yes, that is clustering. Okay, so clustering algorithm is for organizing the data. So if you want to organize any data, then you will go with clustering algorithm. But then how the clustering works? Now imagine you have three chocolates. Say one is red, one is blue, and one is orange chocolate. Orange, and we'll also take one green chocolate. Okay, so how cluster will work is, first you should tell how many clusters should it get created. We are going to tell. We are going to tell how many clusters it should create. Now say I am asking it to create, 3 clusters. Okay, so it will create 3 clusters, and it is going to take 3 color values, 3 chocolate color values. So one is going to be red, and one is going to be blue, and another one is going to be orange. What I'll do is I'll add another green, I'll add another red, and then I'll add another yellow. All right. So it is going to create 3 clusters, and each 3 cluster will have this as a center value: red, blue, and orange. Now, after that, we have another 3 colors here, right? So it is going to check which color is very closest to each cluster. Okay. Now it will check for green. Let's assume green is very closest to this third cluster, this first cluster, second, and third cluster. So what it will do is it will take this green value and it will put inside this third cluster. Then it will check for red. So red, again, it is closest to the first cluster. So it is going to take red value and put it here. And then it will check for yellow. Again, if yellow value is closest to third cluster, it will put it in the third cluster. Now this third cluster has different values, right? Orange, green, and yellow. Now it is again going to start grouping. It will again start grouping, so that, unless and until all the clusters look similar, all the values inside cluster look similar, this grouping will get continued. Okay, this is one type of clustering. And here in this example, if you see, we're using one type of clustering called k-means algorithm. Okay, so in this k-means algorithm, we have different color candies, and you wanted to organize each candies first. So first, what you will do, you will decide how many clusters you want to make. That is the first step. Okay, and then you're going to pick centers. So you're going to randomly pick 3 candies, and you're going to make them as the centers of the group, like leaders of the group. Okay, and then what you're going to do is you're going to group. Now you're going to look at each candy and see which center candy it is closest to. And then you're going to put those candies into that particular groups or that particular clusters. After that, after you've grouped all the candies, you look at each group and find the average color. Like what is the average color which is inside each group. Now that average color again becomes the new center of the group. Now here, for example, let's say you have orange, green, yellow, and you have another orange. So which is the average color which is here in this group? Orange, right? So this again becomes the center of this group, and again the grouping will happen. Okay, so it will keep repeating step 3 and 4 until all, there is no more changes to be done in each cluster. And then the final groups will define the clusters with unique values. Okay, so we'll take same example. Let's say we have red, green, blue, and yellow candies. So in our program, we are going to create a list with red, green, blue, and yellow candies. Okay, 4 candies. All right. So the number of clusters which I wanted to create, if I want, I can give a value here. If I want, I can give 3 or 4 here. But I've just given the length of the candy colors. So what is the length of the candy colors here? What is the length of this candy colors here? How many colors do we have? 4, which means the length is going to be 4. So we are asking our model to create 4 clusters. Okay. If you have restrictions, you wanted to create only 3 cluster or 2 cluster, you can just directly give 2 or 3 here. Okay. So the number of clusters will be 4, and then you're going to extract these values. So you're going to, all this is inside a list, right? So you're going to take that individually and you're going to store it in colors underscore RGB value. You're going to extract those colors and store it in here. And then you're going to pass it to the k-means. So after you pass it to the k-means, we are going to predict. We are going to do the prediction. And here we are not going to pass any training set and all. We want the output as, 4 clusters, and each cluster should have red value, green value, blue value, and yellow value. This is our output. We have not passed any training set here. All right. And then first we'll run and see, and then we'll pass the training set. Okay, so we have the data set, candy colors, and then we are asking how many clusters it should create, and then we are extracting the value, passing it to the k-means classification, and then we are using for loop, and we are trying to print how many clusters have got created. Now, when I run this, I should get 4 clusters created. So in the output, see, we have 4 clusters, 1, 2, 3, and 4. The first cluster has yellow, second cluster has blue, third one has green, and fourth cluster has red. Now, how do you test this? Whether it is clustering properly? How do you test this? You're going to add extra training set, data set here. Okay, extra values here, and check whether it is getting classified properly or not. So for extra training set, what I'll do is I'll give 2 more colors. One is purple and another one is orange. Okay, so purple is going to be another test color and orange is going to be another test color. Now let's see where this purple is going to get added, where this orange is going to get added. I'll run this program again. Okay, I missed a comma. Save, run. Okay, so red, green, blue and yellow belong to each clusters. And see here, we have got another new cluster, 5 and 6. 4 and 1 is for purple and, okay, 4 is for purple and 1 is for orange. Another 2 cluster got created. Now, what if instead of giving length of candy colors, I change this value, I need only 4 clusters. I don't want 6 clusters. If I give 4 clusters, we'll see where the purple and orange gets added, or we'll see which color gets added to which cluster. So cluster 2, that is yellow, it has yellow color and red color. And what is the other one? Okay, cluster 2 has 3 colors. So the cluster 2 has orange color, it has yellow color, and it has red color, which means it considered that these 3 colors are closest to. So it put inside one particular cluster. Now, if I add, instead of purple, let me add red color, comma, red. So when I add red, it should obviously go get added to which cluster? It should get added to cluster which has red value, right? We see whether it is getting added to red cluster. Okay, red belongs to cluster 1. Yes, and again another red belongs to cluster 1. So the algorithm is working fine. All right. This is with k-means algorithm. Classification, right? You have more algorithms like this, but in general, the algorithms which are most commonly used, which are quite easy for you to understand, I've taken only them, and I've tried to make it as simple so it will be easy for you to understand the flow. Now, all that you have to know with these programs is, to understand this program, you should have a good understanding with Python. You have a good understanding with each and every code in Python. Only then you will understand what code, whatever code I give you, when you take and you put it in your PyCharm, it is going to work. It is still going to give you the output. But if I ask you to change something in this and try to get a different output, you should also know that. For that, you should have an understanding of the Python code. Algorithm is something like that only. You have algorithms predefined, but you should know how to take that algorithm and use it according to your requirement. Okay. Now, based on what we've seen today, I have an assignment for you for day 5. So for day 5, you have 2 case studies. All right. One case study is with logistic regression and another case study is with k-means clustering. All right. So with logistic regression, what you're going to do is you're going to predict whether a customer will subscribe to a service based on their monthly income. So I have the data set here. So this is the monthly income. And based on this monthly income, if he will subscribe, the answer will be 1. If he is not going to subscribe, the answer is going to be 0. That is, you're going to find the probability value. So you will write logistic regression for this and you will find out. So this is the this is the question which we are going to ask. If the user is earning 3,000, will he subscribe or not? If he is earning 4,500 or 6,000, will he subscribe or not? For this, you have to find answers. This is one thing. And second one is k-means. So you are going to create a k-means clustering algorithm and you're going to group the customers based on their monthly income again. Okay, so you are going to create 3 clusters. 3 clusters, and here is the monthly income. Okay, now based on this monthly income, you will create 3 clusters, and under 3 clusters, the value that gets assigned to 3 clusters has to be the closest. Okay, now you have 2,000, 2,500, 3,000. Just check the output. Check the output and try to analyze the output, how it is clustered based on the values as per ascending order or based on the values that are nearby, how it is clustering. Analyze the output and then you will submit the screenshot. So again, for these 2 assignments, how will you submit the screenshot? Again, in form, I'll give you one upload link. So you have to upload it as a document. Okay, so in one document, what you will do is in the document you will put case study 1. You'll have the code and the screenshot of the output, and then case study 2, you'll have the code and then the screenshot. In this order, you will prepare one document and you will upload it to the Google form. So I want to see both your code and the output. All right, and yesterday I gave you an assignment with which one? Okay, I asked you to create bar chart and pie chart. Is it done? Did you all do? You all got the output? Yes. Okay. So this is with day 5. All right. And a few things which I wanted to add to this internship is with every day sharing the forms. After sharing the forms, the next day I usually go open the form and see. I see people submitting assignments. It's really nice to see people taking efforts and submitting assignments. What is the purpose of submitting this assignment? What benefit do you get in submitting these assignments based on all the previous internships which we've given for the past 1 month? What we have planned here is we have planned to give you all another 3-month internship. But that 3-month internship is only for participants who have performed well in the assignments. So how are we going to check that? We are going to check all your assignment forms. So all your assignment 1, 2, 3 and 4. 3, 4 and 5. We are going to check each and every assignment of yours. See how you have performed in that assignment. And we are going to select participants from that. Okay, we'll be selecting students, we'll be shortlisting students, and for those selected students, we are going to conduct a small interview. Okay, a small interview based on task. So we'll be giving you tasks, and interview is nothing but a task-based interview. So we'll give you task and we'll see how well you're performing in that. Okay, so if you're performing well in that task, if you're giving us best output, we'll be hiring you as an intern and then you'll be working with us for the next 3 months. But for this, again, we have to shortlist and we have to give all the results. That will happen maybe next week or a week later. All right. But you have this for certificates, attendance is mandatory. All right. If you want your soft copy certificate, you should have given your attendance at least in offline class or in online class when I share the Google Forms. So people who are watching classes in YouTube, well and good. But again, if you want certificates, you have to fill in your attendance sheet during live classes so that you'll get your certificate. So soft copy certificate will be sent to your mail next week. And yes, so this 5 days of internship, I hope I was able to train you with, at least now you should have a basic understanding of what data science is, what flow you should take, what technologies, what terminologies you should be strong with. And yes, if you're interested, grow your knowledge in this field, because for data science you have you know, good vacancies, good job vacancies. You can try even for abroad, and you have market here in India, Bangalore, Hyderabad. There are many MNC companies who are hiring for data science. They are hiring freshers for a good CTC. So if you're choosing this as a career, yes, you should have good programming and logical thinking skills. That is the most important thing in this. And then once you get into a job, obviously you're going to get practice to the environment. Yes. So I hope I'll see you all in another session. And thank you guys. Thank you for your time.